as you all know that what fork does now, and what is parent process and what is child process. Alright, hi all of you, welcome to my first video of process management. Alright, and I will cover some little part of special permission as well. I forgot to cover that in my last video, but in this video I'm also be covering that special permission part, which is related to your others. Alright, so let me first show you that. As I already showed you in my previous video, that let me show you again, that I have created this NFS most wanted directory, and in this directory I have added a special permission to groups. Alright, let me show you to the part of group. Where is my NFS? There it is. As you all can see, there is your S permission. Alright, you can see here, this is your S permission. So this is your special permission. In this video I'm going to show you that how you can add a special permission to other section as well. Alright, so let me show you first that. Alright, let me run that command, which is your grep command. Let me run this command. As you all can see, this is your special permission. As I already showed you, let me just enter in this in this NFS directory. Let me now do ls-l. Now as you all can see that it is showing that this file, this directory is created by a user, and this directory is created by Hornet user. This is created by a, this is by a again a, and this is by Hornet, and also showing the group as I already showed you in my previous video. Alright, so in this video what I am going to show you that how you can add a special permission to this NFS directory, and what is the purpose of adding that special permission. Let me show you that. Alright, let me first log in as sudo not sudo, let me log in as Hornet user. Alright, Hornet user. Now as you all can see, I'm logged in as Hornet user. If I go here, if I do ls-l, as you all know that this directory A is created by a user. Alright, but right now I am Hornet user. Can I delete this directory because this is created by a user and I am logged in as Hornet user? Alright, so just tell me that I can delete or not. If the answer is yes, you are right. Alright, let me run that command, rm-rf. Alright, as you all can see that there is no directory A exist anymore. Alright, so this is a, you can say this is a problem, because anyone can any user can delete which is added in this group. Alright, so he or she can delete anyone's files or directory. So this is also a problem. What is the solution for that? You have to give a special permission. By giving the special permission, by adding that special permission to NFS directory, NFS most wanted directory, only the owner can delete his or her file. Nobody else can delete. Let me show you. Let me first add that permission, chmod. Now you have to write here like O, because I am giving special permission to others. So let me write O plus. Let me first show that ls. Let me first show what are now permission. Alright, let me run the command. Let me just go back from here. Now let me run command ls-l using pipe. As you all know, pipe in top level 2 directory, pipe, and now it's time to use the grep command, nfs most wanted. Alright, most wanted. Now as you all can see that there is no permission in other section. Alright, so let me just do one thing. Let me just exit from here, because now I am Hornet user. First I have to be a root user for that. Now let me just do one thing. Let me just run the command chmod o plus t, because this permission name is sticky bit. Alright, you can search on Google as well. This permission name is sticky bit. Alright, so that's why I'm writing T instead of S. But this is also a special permission. Alright, but its name is a T, sticky bit. Alright, so O plus T, in which for which directory I am giving this, for NFS this. Now let me show you. Now you can see that the T is appearing. Alright, it means you have given the permission, you have given the sticky bit permission. So let me just now log in as a user. Alright, a user. So let me just go there. Let me go in this directory ls-l. As you all can see that this directory is created by Hornet. Now I am a user. So let me just ask you one question, that I can delete this directory or not. If your answer is yes, I can delete, so you are wrong. Let me show you that. While doing rm-rf directory h, because this directory is created by that user. Now you can see that. Let me just run this command again, ls-l. Now if I delete this directory, now you can see that rm cannot remove directory h. Operation not permitted, because I have added a special permission. Only the owner can delete. If I delete this file, because this file is created by a user and right now I am logged in as a user, so if I remove this file, now you can see that. Let me just run this command, rm-rf file a. Alright, so let me just ask you now one more question, that this can I delete this file now? If your answer is yes, you are right. Alright, let me show you. Now as you all can see that now my directory is deleted. Now as you all can see, my file is deleted, because that was my file. As you all can see that my file is not there anymore. Alright, so I hope you got the concept, what is the concept running behind this. Alright, so just let me close my server. Alright, let me stop my server for now, and now let's move on to the main purpose of this video. What is the main purpose? Process management. Alright, so this video is all about process management. Alright, so I am starting a new chapter. Alright, let me now talk about that. What is process? Let me ask you, what is a process? So if I am running this putty, this is also a process. If I am running this Google, this is also a process. If I am running this whiteboard, this is also a process. Everything which is running on operating system, that is process. Alright, so let me talk about some basic command that let me just show you. So let me just show you. Now you can say this is my let's say this is my command. Alright, this is my command, and this is its actual output. Alright, if I run a date command, let's say I run the date command. Alright, as you know that there is no dependency in date command. You just run command and the Linux will show date. Alright, so there is no process going in the backend for this command. If I run that pwd present working directory, that is also similar kind of a command. There is no dependency for this command as well, but there are some more commands which have dependency. Alright, so let me talk about those commands. Now let me talk about this. Alright, if I create a user, alright, if I create a user by running user add command, some more process run behind the scenes which you can't see. Alright, so those processes are known as child process. Alright, those processes are known as child process. So like this, you have run this command user add here. Alright, so there are some child process like in the home directory, in top level root directory, in home directory, there a directory also created by name of user. Alright, so this is you can say a child process, first child process. Also when you create a user its entry will also be done in etc password, this file. As you all know, this is second dependency, you can say. And as I already told you in my previous videos, that when you create a user, its group automatically creates. So there is another dependency, etc group, which means a group will also create automatically by default. Alright. Also in var spool mail, a directory also created by the name of user. Also there is another dependency. If you have created a password for that user which you are creating, as you already know that its password is saved in this etc shadow. Like you can see the whole details of the password in etc shadow. One dependency again. So these dependency are known as child process. All right, these dependencies are known as child process. All right. So let me just talk about this fork. What is this fork? All right. So whenever your main task, your, let me just call that parent task, whenever you execute the parent task, there are some child process. So at that moment when the child process are running, your parent process gets on hold. All right. So what this fork does is, this fork will holds your parent process. All right. So let me just show you what is my parent process. All right, this is my parent process, this is my parent process. All right, and these are my child process, these are my child process. So when these child process are running, what fork does, let me write here with this one, fork. What this fork does, this fork will assign a PID to each of child process. What is PID? Let me show you. Let me just open my task manager, and now as you all can see, these are my tasks, and these processes right now are running. So let me just open this services. As you all can see that this is my PID. What PID means? Process ID manager. All right. So what this fork does is, this fork will assign PID a unique. PID always be unique. All right. So the fork will assign PID to each and every processes, and also fork will assign PPID to parent process, because this one is your parent process and these are your child process. All right. So fork will assign PID to child process and PPID to this parent process. What is PPID? Parent process ID. All right, and these are only process ID. So when these child process are executed and they are finished, they have done their work. Now when the child process are done with their work and they are finished, after that what fork will resume the parent process, and now your user is created. It means you can say that these child processes are running in backend in milliseconds. They work, but you can't see. All right, but but you should know the workflow. What is the workflow, how these process work. All right. So what this fork does, this just do one thing. This holds this holds a parent process and executes all these child process. After when the child process are done with their work, it resumes the parent process, and your user is created. All right. But there are some processes, let me show you here. There are some processes, let me show here. There are some processes, let's say that this process is stuck. All right, this process is stuck. So this process is known as zombie process. All right, zombie process. In language of Linux, this is known as zombie process. All right. So whenever a child process stucks, so it means that process is known as zombie process. And let me talk about the zombies. What I just want to ask you all that what zombies do on Earth, as you already watched some movies on zombies, and some web series on zombies. So what zombies do? As you already know that zombies just acquire space on Earth and do nothing, irritates. And similarly in Linux, these processes just acquire your space in from your hardware, also irritates you. So what is the solution? So what is your work? So your work is to just monitor on these processes and just kill them. Monitor on these processes and kill them. Your work is just this. All right. So I think this is the workflow. This is the right workflow of process management, and you can also look at this blog. This is a really great blog. All right. So yeah, that's about, I think, for today. An example with the zombie process. Alright, so those processes are known as zombie process, which are stuck in your memory, which are stuck at the moment that processes are known as zombie process. Alright, and as you all know that what fork does now, and what is parent process and what is child process. Alright, so I think yeah, this is enough for today, and in the next video I will show you, in the next video I will share you, I'll share with you some more details of process management. Alright, what is the flags of process management. Alright, in the next video I will show you that. I think this is enough for today. Alright, so I will meet you in my next video.
मना के वेख लिया, हंसा के वेख लिया।